Hello and welcome back to this lecture series on signals and system. Alright, so now let's talk about the periodic signal. So from the definition, you might need to also take this down. So a signal x of t is said to be periodic with period t if it exhibits periodicity. So that's what we mean by a periodic signal. That means a signal x of t is said to be periodic with period t if it exhibits periodicity. So what it means is that if you have a signal, okay, if you have a signal x of t, so this is more like the mathematical representation of a periodic signal, is equals to x of t plus t. Exactly. So where this t is the period of the signal. Now let me give you a more simpler definition if that is not clear. So a signal is said to be periodic if it repeats itself after a regular interval of time. Exactly. Now using this diagram that we have here as an example, if you look at this pattern, you see that it is repeating itself after a particular interval. It is from 0 to 0.5, from 0.5 to 1. You can see that it is repeating itself after an interval of 0.5. It keeps repeating itself. So once you have a signal like this, you can call it a periodic signal. Exactly. So what we are having here, this first one, is a periodic signal. So I've given you two definitions of what a periodic signal is, while what we are having here is a periodic signal. So again, a periodic signal, a signal is said to be periodic if it repeats itself after a regular interval of time. You have to take note of that word, not just repeating itself, but after a regular interval. Like I said earlier, from 0 to 0.5, you can see that it's the same interval. So if you look at it here, it's the same interval from here to here, and the difference is similar, 0.5, 0.5. It increases by 0.5. So there's a regular interval at which it repeats itself. So that makes it a periodic signal. But once it did not satisfy what we've just said about a periodic signal, then we can conclude that it's an aperiodic signal. An example is this diagram we're having here. So this diagram is a representation of a periodic signal. All right. So in addition to okay. All right, so let me also add this to it. Now, if you have a question, so let me just mark this part. So if this is just like a question under periodic and aperiodic signal. Let's say we have a question like this, that x of t is equals to 5 sine 2 pi t. Sorry, my handwriting is bad for some reason. So if you are asked to find the period of this particular signal, so what you are just going to do is, now remember from w is equals to 2 pi f, and remember that f is 1 over t. So you're going to be having so w is equals to 2 pi over t, where t is the period. All right. So don't forget f is 1 over t. So let me just explain what I did here. So we have f is equals to 1. Sorry, f is equals to 1 over t. So if I should replace this f with 1 over t, we'll be having 2 pi over t. So now once you have a question like this and you're asked to calculate or to find the period, so what you just do is you just bring the value before the t, before t here, because what we're having here is the same thing as having 5 sine wt. Exactly. So this w that we are having here is the same thing as 2 pi over t. So what we'll just do is we'll say 2 pi over t is equals to 2 pi. So this 2 pi is the value before t, before letter t here. So what we are going to do here is to just make t the subject formula, and in doing that we are going to be having, so that means our t will be equals to 2 pi over 2 pi equals to 1. So that means for this particular question, the period for this particular signal is 1. So that means our t is equals to. So now let's look at another example. So let's look at, let me pick another example. So if you have something like x of t, so here we have x of t equals to 1 plus cos 4t plus 1, and you're asked to calculate the period. So don't forget, we've established the fact that w is equals to 2 pi over t. So you're going to replace it with whatever it, you're just going to equate it rather to whatever is before this t, which is 4. So we're going to have equals to 4. So if you are to solve this, we are going to be having, making t the subject formula, let me write this, 2 pi over t equals to 4. So that will give us, if we make t the subject formula, we are going to, okay, let me just cross multiply so that you don't miss it. So that will be 2 pi equals to 4t. So that means our t will be 2 pi over 4. And that's this one, and this is 2. This is going to be pi over 2. So that means the period for this particular signal is pi over 2. So that is it there. Now let's look at one last example that I'll be doing here. So if you have this like something really different, so if you have a signal like this, x of t is equals to 2 cos 4 pi t, which is small letter t, plus this 3 sine 3 pi t, Alright, so how do we go ahead to look for the period for a question like this? Now you can see that we are having some this 2 in 2 places exactly. So we pick it one after the other. So that means we're going to be having 2 pi over 4. 2 pi over t is equals to 4 pi. So now let's make t subject formula. We're going to be having 2 pi is equals to 4 pi t. So that means our t will be equals to 2 pi over 4 pi. And this will be 1 over 2. So let's call this our t1. So let's call this our t2. Now for 2 pi over t equals to now 3 pi. Are we good? So if we should cross multiply, we are going to be having 2 pi equals to 3 pi t. So that means our t will definitely be, so if you make t subject formula, that means you're going to divide both sides by 3 pi. So that will be 2 pi over 3 pi. So pi can cancel pi, you are going to be left with 2 over 3. So let's call this our t2 equals to 2 over 3. Alright, so for us to get the period, what we'll do here is we just equate equation 1 over equation 2. So that means we're going to be having t1 over t2, and that's going to be 1 over 2 divided by 2 over 3. So that's 1 over 2, so times 3 over 2. And that will give us, so that means t1 over t2 will give us 3 over 4. Now if you should cross multiply, we are going to be having 4t1 equals to 3t2. Now, alright, so at this point, remember we are calculating for the period. But at this point, you can be asked that for this particular question, for this particular signal, is it periodic or aperiodic? Now, once you have t1 over t2 and you are having a rational number, you can conclude at this point that the signal is periodic. Exactly. So you can conclude that it is periodic at this point. But, and you want to now go further to calculate for the, what do we call it? For the period, that we call it fundamental period. So once you get to this stage, remember we have our 4t1 is equals to 3t2. Now let's substitute the value of t1. You already know that our t1 is 1 over 2. So that means you're going to be having 4 times 1 over 2 equals to 3t2. So this is going to give us 1 and this will give us 2. So that means you're having 2 equals to 3 t2. So take note of this. Now, if we also, from here where we have 4t1 equals to 3t2. Now if you bring in the value of t2, t2 is 2 over 3. So that means you're going to be having 4t1 equals to 3 times 2 over 3. And that's going to give us 2. So that means our 4t1 equals to 2. So you can see that we're having 2 here is giving us 2 here. So with this now we can conclude that for this particular question where x of t equals to 2 cos 4 pi t plus 3 sine 3 pi t. So we can conclude that for this particular one, the fundamental period, So you can conclude that the fundamental period is what? Is 2 seconds. And also, we've also established the fact that this is a periodic signal. A periodic signal. And why is it a periodic signal? Because when we look at T1 over T2, it's giving us, where is it? Okay, it's giving us 3 over 4 equals to 3 over 4, which is a rational number. Which is a rational number. So, with that's all I want to cover under periodic and aperiodic signal. I hope you find value in this video. If you have any question or any doubts, do make sure you leave them in the comment section below. So, in the next part of this lecture series, we are going to be looking at the even and the odd signal. So, thank you very much, and I'll see you all in the next one.